This is a video about probability. There are many misunderstandings about probability, and I will correct a few of them in this video. Probabilities, whatever else they might be, are numbers that obey certain rules called the calculus of probability. I shall now explain those rules. A quick disclaimer: despite the talk of betting in this talk, I do not recommend gambling. Probabilities PA, PB, and so on are numbers assigned to objects represented by sets labelled A, B, and so on. They act a bit like the areas of the shaded regions in this diagram. The red area might represent PA, and the blue area might represent PB, for example. PA or B, which is the probability of A or B or both, would then be equal to the area of the two circles minus the area of the overlap. That is, PA plus PB minus the probability of A and B. The probability of A, given that B has happened, is written as P A conditional on B, and it is given by the probability of A and B divided by the probability of B. For example, if you toss a die twice, then the probability of getting 2 sixes is equal to 1 over 36. The probability of getting 1 6 is 1 over 6. So the probability of getting 1 6, given you've already had a 6, is 1 over 36 divided by 1 over 6, which is equal to 1 over 6. Suppose that you are measuring some quantity A, and each value, A, B, C, and so on, comes up with a particular probability. The expectation value of A is the probability of A times A plus probability of B times B plus probability of C times C, and so on. For example, if there is a probability 1/3 that an ant will walk 5 centimeters in the next 10 seconds and 2/3 that it will walk 10 centimeters, then the expectation value of the length of the ant walk will be 1 over 3 times 5 plus 2 over 3 times 10, which is equal to 25 over 3, which is equal to 8 1/3. The relative frequency of a type of event in a particular set of events is the proportion of times that it happens in that set of events. For example, if I toss a coin 5 times and get heads 3 times, the relative frequency of getting heads is 3 over 5. When we want to do experiments to measure the probability of X, we measure the relative frequency of X for a large number of experiments and then say the probability is close to the relative frequency. The reason we can do this is that the expectation value of the relative frequency is close to the probability for large numbers of measurements. Many people say that probability just is relative frequency, but this is wrong. If probability was relative frequency for a finite number of trials, then it would not have a definite value. For example, if I tossed a coin 5 times and got heads 3 times, the relative frequency would be 3 over 5. If I tossed it again, it might come up tails, and the relative frequency of heads would then be 3 over 6, which is equal to 1/2. To solve this problem, advocates of the relative frequency theory of probability say probability is the limit of the relative frequency in an infinite number of trials. However, we can change this limit by rearranging the order of the events. For example, if I toss a coin and get HT, 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 then the relative frequency is 1/2, right? But if I move the t's up the line in the right way, I can get the sequence HHT, 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 and so on, and the relative frequency is 1/3. So the limit is not unique. There is a much bigger problem though. The relative frequency theory does not tell us what events should be considered the same or why. Also, it does not constrain what happens on any particular occasion, and so does not explain how I should act on any particular occasion. For example, if the probability of getting heads is 1/2, then a probability's relative frequency it could easily be the case that the coin will come up tails on the next toss. So why should I not act as if tails will come up, instead of taking account of both heads and tails as possibilities? The decision-theoretic theory of probability states that if all you care about is the amount of money you will win, you should rank bets according to the expectation value of how much you will win. You should update your probabilities for A when you see B by changing your probability for A to the probability of A conditional on B. And if you bet any other way, people will be able to win money off you. The decision-theoretic theory of probability does not allow you to assign probabilities at random. If I play a die tossing game with you and I know the die is unfair, then I can win money off you. So probability is objective and not subjective. The right probabilities to bet on are the ones in the real world given by the real laws of physics, not the ones you happen to think are real. You should not assign probabilities to your theories about the world, because what matters for whether you win bets is what actually happens, not what you think will happen, i.e. your theories about how the world works.